In this video, we are going to be looking at section 6.1 called Ratios, Proportions, and the Geometric Mean. So this will be the first lesson in our chapter 6, which is on similarity. So the first thing we would like to review is what is a ratio of A to B. So if A and B are two numbers or quantities and B is not 0, then the ratio of A to B is stated as A to B or A to B in this format. So a ratio always has the same units. So the same units. That's what makes it a ratio. So boys to girls in the class, or apples to oranges, or 2 parts to 1 part. So the next thing would be, what is a proportion? Well, a proportion is an equation that states two ratios are equal. Two ratios are equal. Now, we typically see this as this proportion. So A to B is to C to D. Now, the A here and the D here, these are called the extremes. So these are the extremes. Now, C and B, these are called the mean. The mean. Now, there's a couple of things we have to know when we are looking at this proportion. The first thing is that B cannot equal 0 and D cannot equal 0, because if those do actually equal 0, then we would have an undefined proportion. So if everything here is true, then the way that we can solve this is simply by cross multiplying. So we could multiply the A and the D and the C and the B, and then we would end up getting A times D, so that would be here, equal to C times B, which would be here. Now, one thing to remember though is that this is going to be two equal ratios. So 2 to 3 equals 4 to 6. So it's a proportion that's set equal, and it's two equal ratios. And if we check 3 times 4, we get 12, and we check 2 times 6 and we get 12, then it is a true proportion. Now let's look at two examples of ratios. It says, find the ratio of the width to the length of the rectangle. Simplify the ratio. Now, please keep in mind that the ratio must be same units, and the order matters. This says width to the length. So when we do our ratio, it must be width to length. So you can see here that 4 centimeters is the W, and you can see that L is 12 centimeters. Now, the very first thing I notice is that centimeters and centimeters will cancel out. So the units will cancel out. Then we can reduce this to 1/3. So that's going to be our ratio, 1/3, and the centimeters canceled out. Now, as we look over to B, we still must do width to length, but the problem with this one is we have 1 foot to 18 inches. So the first problem is feet and inches. That's not a ratio, that is a rate. So we have to convert. So the easiest thing to do was to use the conversion factor. There's 12 inches in 1 foot. Now the reason why I do it this way is that the inches and the inches will cancel out, and the feet will cancel out, and now I can simply multiply straight across. So I can say 12 over 18, reduce that down by 6, so that is a ratio of 2 to 3. Now, looking at ratios in a little different context is on a number line. So number 2 says, use the number line to find the ratio of the distances. Again, we must follow the ratio in order. So from A to B is here, that is 2 units. And from C to E, it is from 6 to 14, so that is going to be 8 units. So 2 units to 8 units reduces to the ratio of 1 to 4. Now, if I look at the next problem, I have B to E, which is from here to here. So 14 minus 2 will be 12. And the length of CD, if I look from here to here only, so here and here, that is from 6 to 9, that is going to be 3 units. So this one is going to be a 4 to 1 ratio. Now remember, since we are doing ratios, you keep the 1. Now, an application in geometry will be like number 3. It says you are painting barn doors. You know the perimeter of the barn doors is 64 feet, and the ratio of the length to the height is 3 to 5. Find the area of the doors. Well, the first strategy that we would need to do is we would really need to draw the barn doors. So we are going to draw the doors. They would look something like this. This is typically what a barn door would look like. But it says that the perimeter is 64 feet. So I'm going to start with that information. The perimeter is 64 feet. And it does not tell us what the actual length and height of the barn doors is, but it does tell us some information. It does tell us that the length is 3 to 5. So 3 to 5. So our picture is probably not to scale, but we can still use this from 3 to 5. So the strategy that we would do is we don't know what these are, but we do know it's a 3 to 5. So we can put x's with the 3 and the 5x. Whatever the x will be, the ratio must stay true of a 3 to 5. So we can now institute the perimeter formula. The perimeter of a rectangle is 2L plus 2W, and we can substitute in what we have. So P equals 2 times 3x plus 2 times 5x. And the P we can replace, and we can actually put a 64 in there. Now, cleaning this up, 64 equals 6x plus 10x. So 64 equals 16x. Divide by 16. And I get 4 equals x. But I am not finished. So since I know 4 is equal to x, I can now bring 4 over here. And this is going to give me 3 times 4, which is 12 feet, and 5 times 4, which is 20 feet. Now, a quick check of this will give me the perimeter back. So if this is 20 and this is 20, that's 12 and 12. Yes, it does give me 64. And yes, 12 to 20 has a ratio of 3 to 5. But I am not finished with this problem. The problem clearly states for me to find the area. So now that I have the dimensions, it is 12 feet by 20 feet. I can now find the area with the area formula. So the area equals 12 times 20. So the area of these barn doors will be 240 square feet. Now, that was dealing with sides, and question 4 is dealing with angles. Now, I have already helped you out by giving you the picture, so I would like for you to pause this video and work out number 4. Okay, in this problem, it is talking about an extended ratio. So you can see that it's a 2 to 3 to 4. So I have provided a triangle for you with the 2 to 3 to 4 relationship, and you add those x's in there, and then you use your triangle sum property to solve this. So you do 2x plus 3x plus 4x equals 180 to come up with x equals 20. Once you get x equals 20, you will find that this angle is 40, this angle is 60 degrees, and this angle is 80 degrees. Now, how do you know this is correct? because a 40 to 60 to 80 is an extended ratio that reduces down to a 2 to 3 to a 4. Now, the next thing on our note says solve the proportion. Now, I know you have solved proportions before, and this one is no different. We will be solving lots of proportions with similar triangles. So you're just going to use what you know all about math to solve these proportions. So, for example, this one, we would say 5x equals 2 times 8, which is 16. Divide by 5, divide by 5, so x equals 16/5. As always, you can check these answers. 2 over 16/5 equals 5 over 8. And if you cross multiply, 2 times 8 is 16, and 5 times 16/5 is also 16. So you know you have a true proportion because each ratio is equal to each other. Moving on to number 6, a little bit more algebra in this one. You are going to cross multiply, and please do not be lazy here. You really need to show your work, use those parentheses, otherwise you will forget to distribute the 2. And then you're going to cross multiply this way, and you're going to get 3y. So now distribute the 2. 2y plus 2 equals 3y. Let's take this 2y to the other side, and you get 2 equals y. So y equals 2. So now let's check this. We have 1 over 2 plus 1, and we have 2 over 3 times 2. So on this side we have 1/3, and on this side we have 2 over 6. And you can see that 1/3 equals 2/6 because 2 times 3 is 6, 1 times 6 is 6, or 1/3 simply equals 1/3. Now, let's move on to question 7. Question 7 is going to get a lot more algebra involved because when we cross multiply, when we say x times x, we get x squared equals 8 times x minus 2. So the first thing you need to notice is, okay, an x squared popped up, therefore I have a quadratic. So you have to know how to solve quadratic equations. So let's continue here. We have x squared equals 8x minus 16. That is not in standard form, so we're going to bring the 8 over and the 16 over, and we get x squared minus 8x plus 16 equals 0. And then this is where you must decide which method you are going to use to solve the quadratic. You have factoring, completing the square, quadratic formula, graphing, just to name a few. But I can automatically see that this looks like this is going to factor. So I am going to choose the method of factoring because I can see factors of 16 that will give me 8 will be 4 and 4. If I make them both negative, then I can get a negative 8 in the middle. Now, I have two identical factors, so x equals 4 when I set x minus 4 equal to 0 and solve. Now, I only need to list one answer because they are the same answer. If I want to check this, I would simply say 8 over 4 equals 4 over 4 minus 2. So this is 8 over 4 equals 4 over 2. And yes, it checks. So here is a look at a simple problem dealing with just one x. A little bit more algebra involved. Do not forget your parentheses. And then if a quadratic pops up, solve the quadratic like you know how to do. Now, the next problem, as you flip your notes to the back, will be number 8. This is an application problem of where you do proportions. So please stop the video, read the question, and solve this. Okay, so for number 8, go ahead and check your work. I set up the ratio of the number of rows and the number of lanes, and then I set them equal in a proportion. I solved and got 936.